Welcome. My name is Joanne Caniglia. I teach mathematics education at Kent State University. The title of my talk is Extending Mathematical Modeling to Include Social Justice and Civic Engagement. The purpose of this presentation is to describe the relationships among problem-solving, mathematical modeling, social justice, and civic engagement with sensor ideals. So what is a problem? It's a task that requires mathematics to solve the problem. A task requires unpredictable methods and no particular algorithm is defined. And a task requires multiple solutions and multiple pathways. So what is mathematical modeling? A task embeds an authentic real-life context. A task that includes an iterative process of testing mathematical solutions in real life, the context to make reconciliation between math and the real world. Mathematical modeling can also be involved with social justice. In that case, it's a task includes a context related to social justice or requires to discuss social justice issues with a context or solution. Sensor connects science and civic engagement by teaching through complex and unsolved public issues to basic science. Sensor improves science education by focusing on real-world problems and extends them. This year marked the 50th anniversary of May 4th. I'm now going to share with you 3 examples of how civic engagement can be involved and with the COVID. Because of the virus, no one was on campus to memorialize the event. In the May 4th Museum at Kent State, there is a timeline of events. At one point, December 1969 included a chart of dates and the order of the draft lottery, in part the students' protests at Kent State. This was the sign of the lottery in which the order in which the young men would go to Vietnam. By choosing lightweight balls with numbers on them, the order of the numbers pulled represented the order of the draft lottery. My students and I soon discovered that it was not fair, and so they investigated the data. Box and whisker plots and line plots, regression equations, all helped them to see that this was a biased lottery. Next, during the early days of the pandemic, the elderly are the most involved and the most vulnerable. This year, Meals on Wheels was in need of volunteers to drive, and so we tried to optimize their trips. We used the Sierpinski space filling algorithm in which any point in the city would be on a particular curve. So a set of random points and a traveling salesman problem, this is most certainly like that. It's according to their relative position along the space filling curve. In a sense, it is a function from a 1 dimension to 2 dimensions, and it will give you an ordered pair. Next, my students were concerned with how to avoid the summer and the virus slide. Our concern was for those who were not and did not have online technologies. Most had phones, but no internet. To see a class on a cell phone was not acceptable. So my students created STEM break bags. They were filled with 4 to 5 STEM activities that children grades K through 5 can accomplish. With the help of foundations, pre-service teachers, and others all participated. This is my favorite picture. This young woman was so proud of her catapult. The children learned about circles and how far apart 6 feet was by making a large circle with a radius of 3 feet and diameter of 6 feet. I will hopefully be sending along resources for break bags so that you can see those. You can also see that they're aligned with K-12 Next Generation Science Standards and the Common Core. I use Bringing Science Home from Scientific American. And here's my contact information. I hope that this was helpful to you. Please do not hesitate to email me. And thank you. And if you have any questions, I'll be more than happy to answer them when we have our discussions together. Thank you.